SpaceX is building the biggest rocket in human history, and its survival, it all comes down to a shape you'd probably find on a bathroom floor. It sounds crazy, but this is the story of Starship's hexagonal secret.
Okay, so picture this. A spacecraft slams back into the atmosphere. The air can't get out of the way fast enough. It gets crushed so violently that it literally rips apart into the soup of superheated electrons. We call it plasma, and yeah, it is hotter than the surface of the sun. And all of this is happening at a speed that's just, well, it's hard to even wrap your head around it. 25,000 kilometers per hour. At that kind of velocity, you are not just flying through the air. You are in an all-out war with it, every single inch of the way. And this plasma, this superheated chaos, it has one job, one single-minded goal: get through that heat shield and start eating away at the steel skin of the ship. It's the ultimate showdown, It's engineering versus the raw, brutal power of physics.
So how in the world do you solve a problem that's literally as hot as the sun? Well, SpaceX's solution, it looks almost deceptively simple. It's just thousands of black ceramic tiles. But the real genius here isn't just the material, it's the shape.
And believe me, the stakes could not be any higher. This one little choice, something you learned about in high school geometry, is the fine line between a safe landing and a complete and total catastrophe. So the question is, why? All right, let's start with the most obvious choice, right? Squares. I mean, they fit together perfectly, they're easy to make, it seems like the ideal simple solution. But here's the thing, in the world of hypersonic reentry, the simplest solution is often a deadly trap. So here's the fundamental problem you have to solve. You can't just use one giant solid heat shield. Why? Because the rocket's huge steel body bends and flexes and expands with all that heat. A single shield would just shatter instantly. So you need individual tiles that can shift around, kind of like scales on a dragon. But those gaps between them, the very gaps you need to have, that's exactly where the plasma is going to attack. Which, of course, brings us right back to the central mystery here. If you absolutely need tiles, and squares are the easiest shape to work with, what on earth makes them so incredibly dangerous? Okay, I want you to imagine the gaps between square tiles as long, straight, totally uninterrupted hallways. You've got all this high-pressure plasma building up on the outside of the ship, and it sees those hallways as a perfect, straight shot to the low-pressure area right behind the tiles. And when you force that superheated gas down a straight, narrow channel like that, something truly terrifying happens. It's no longer just a diffuse cloud of heat. No, it consolidates. It focuses into a coherent, high-speed jet of pure destruction. This isn't just a theory. It's a fundamental principle of fluid dynamics called flow acceleration. By giving the plasma a straight path, you're not just letting it sneak in, you're actively weaponizing it against your own ship. The end result is a jet of plasma so hot and so fast that it basically becomes an industrial plasma cutter. It would just blast right through the glue holding the tiles on and then slice through the steel hull itself. In other words, it is a death sentence. So, if squares are a death trap, how does a simple little six-sided shape manage to save the day? Well, this is where we get to see the hexagon's genius. And this is it. This is the whole secret. And it's so brilliant and elegant. Just look at the gaps between hexagonal tiles. There are no straight hallways. There's no direct path for that plasma to follow. So the plasma dives into a gap, but bam, it almost immediately slams into a corner, forcing it to make a sharp turn. Every single time it turns, it creates turbulence, which robs the plasma of its energy. So instead of speeding up into a jet, it just tumbles around, slows down, and becomes this weak, confused little cloud of gas that can't do any damage at all. This is a classic engineering principle, and it has a great name: creating a tortuous path. You're not trying to completely block the flow. You're just designing a pathway that is so inefficient, so convoluted, that the fluid, in this case, plasma, basically just defeats itself along the way. It's an incredibly elegant way to control these immense forces. So here's the bottom line, right? Squares create a straight path, which gives you a focused, destructive jet. Hexagons create a tortuous path, which gives you a turbulent, harmless cloud. It's the same plasma, the same tile material, but the geometry leads to a completely different and life-saving outcome. And what's really amazing about all this is that this super high-tech solution, it's not new at all. It's actually borrowed directly from the natural world. It's basically nature's perfect speed bump.
The real elegance here is that it's a totally passive system. There are no computers, no moving parts, just simple geometry doing all the work. Nature uses hexagons in beehives for strength and incredible efficiency. SpaceX is using them to create thousands of tiny microscopic speed bumps that save a multi-billion-dollar spaceship. And I think that's the real takeaway here. When we're faced with one of the most extreme, hostile environments that humans have ever tried to conquer, the answer wasn't some impossibly complex new technology. Nope, it was a simple shape hidden in plain sight all along.
So the hexagon saves Starship from the dangers on the outside, but what about the dangers on the inside? Well, next time we're going to look at what happens when a simple valve, a part that costs just a few dollars, fails on a $4 billion spacecraft and leaves astronauts totally stranded. I'll see you then.